Hello, Algebra 1B students. This is Mrs. Gregory. Today we're going to be doing notes on lesson 14 and we'll be on page 74. We are going to do in the next couple of weeks a series on probability and statistics because I'm not sure that we have ever had that. So I wanted to go back and start from the beginning of basic probability. So our lesson today is determining the theoretical probability of an event. All right, so I want you to be on page 74 so you can follow along with me. All right, and one of the biggest things I need to make sure we're doing right now is getting through some of these vocabulary words. And so I know that if you've had this already, forgive me, but if you have not, you'll be glad that I did this. So let me go ahead and get started. We're going to talk about sample space, what a simple event is, and how to calculate the theoretical probability, okay? So let's go ahead and get started. I went ahead and wrote down some of the very basic vocabulary words right here. One of them is the very first one they put on there is called a sample space. Let me go ahead and say that the sample space is a set of all possible outcomes of an event. And let me go ahead and say that all possible outcomes, let's say an event happens to be flipping a coin. If the event is flipping a coin, the sample space would be heads and tails. Those are the only two outcomes that could possibly come from that. So I just wanted to put that number, that word in your head so you kind of understand it. And then the next thing I want to give you a vocabulary word is simple event. I wanted to go ahead and define it as an event that's having only one outcome, okay? A simple event, flipping a coin, spinning a spinner, rolling a die, all right? Those are simple events, all right? One thing can happen. Then the next thing is theoretical probability. Theoretical probability is a ratio, okay? And it is determined by the number of favorable outcomes over all possible outcomes, okay? And we'll talk about what that means, but this is very crucial to understanding theoretical probability, all right? Very crucial, all right? So keep that in mind. Write these down if you do not already have them, okay? So let's go ahead and get started and talk about sample space and outcomes, all right? Now, like I said, sample space is normally all the options. So in this case, example 1, a number cube is labeled 1 through 6 is rolled, okay? It's labeled 1 through 6 and it's rolled. So I'm going to tell you that my sample space, my pen's dying on me, sample space, by the way, the sample space is 1, 2, 3, 4, 5, and 6. That's the sample space for this event. Now, the instructions for this is to list outcomes for each event, okay? And the outcomes that we're going to look for, it says a number less than or equal to 3, all right? Of these options, 1, 2, 3, 4, 5, 6, a number less than or equal to 3 are outcomes, our list of outcomes, or favorable outcomes, I want to use that word, is 1, 2, or 3. And it's in a set form because this is a set, all right? So these are the outcomes for a number less than or equal to 3 in this specific event. All right. Now, it says an odd number, where n is odd. So if I look in my sample space, which values are odd? 1, 3, and 5. And so that's my list of outcomes. And I'm going to say my list of favorable outcomes for this specific event. And then C, it says a number greater than 4. All right, you have to be very careful with this greater than because it didn't say greater than or equal to. So my outcome is going to either be 5 or 6. That is my favorable outcome for this situation if I want a number greater than 4. Okay, greater than 4. All right, let's move on. Now, the next thing we're going to talk about is the complement, complet, not an I, complement. It's like a completion word. The complement of event is a set of all outcomes that are not in a given event, all right? It's not in a given event. So there's a probability of an event, and then plus the probability of not that event should always equal to 1 whole. Let me give you a quick example. We see this. All right. If the weatherman says there's a probability, a 30% chance of rain in our forecast, right? Then the complement says that there's a 70% chance that it won't rain, of no rain in our forecast, okay? This is what we call complement events. They're the exact opposites. One's raining, the exact opposite is no rain. And when we add these two events, 30% plus 70% is equal to, 100%, by the way, which is equal to 1. All right, so that's kind of the idea of a complement event. All right, and we'll talk a little bit more about that in the next couple of examples. But I wanted you to see this kind of thing. They made this very formal looking in your book, and it's not really that big of a deal. All right, but the probability of an event plus the probability of not that event, always, the sum of those will always equal to 1 whole, or 100%. Okay? All right, let's move on. I hope that was enough information on that. All right, let's go on to example number 2. Let me make sure I've got this straightened up. I don't want to lose you guys at all. Okay, so let's go ahead. Example number 2 talks about calculating theoretical probability. All right, we're going to calculate theoretical probability. Theoretical, by the way, has to do with that we given a situation, and if all goes well, this is the way it should be. There's another kind of probability called experimental probability, which soon we will get into that. But right now, theoretical is what we're dealing with, because we're saying this is the circumstances, and if all the circumstances are exactly right, this is what should happen. All right. Now, there are 4 green, 3 blue, and 3 red marbles in a bag. So I got this bag, right? And in this bag, I have these marbles. All right. The question is, all right, let me write green, 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 blue, 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 red, red, red. Okay, so there's my marbles, and they're different colors. And it says, what is the probability of choosing a red? What's the probability of choosing a red marble? So I normally would write here probability and write red. This is a simple event, all right? And so as we mentioned before, a probability of an event is the number of favorable outcomes, all right? So we're looking at favorable outcomes over all outcomes, all possibilities. So this is the formula we're going to use. So I come up here. How many are red? 3 are red, right? 3 are red. How many marbles are in the bag? 4 plus 3 plus 3. We add all the marbles. We end up with 10. So we end up with 3 in 10. All right. It says 3 in 10. So A would be 3 in 10. So they want us to give the answer in decimal and as a percent. And so it's 3 in 10 chance, or a 0.3, or you could say a 30% chance. Okay, so these 3 things equal each other. Hopefully we all know that. But there's a 30% chance that if I stick my hand in here, totally random, stuck my hand in the bag, can't see it, I'm going to pull one out. There's a 30% chance that I am going to pull a red marble. That's what that means. Okay, let's go on to the next part of that be, actually, let me get that page back out because it's the same circumstances, but this time it says, what is the probability of randomly choosing a marble that is not green? Okay, so let's talk about this. So I want the probability of not green. All right, this is what we call, in a sense, when we use the word not, a lot of times that's one of our complement events. But how many of these are not green? So I come over here, there's 4 green, 3 blue, and 3 red. So it would be 3 blue plus 3 red, and out of how many that are all in there? 10, which is equal to 6 out of 10, which in the end becomes a 0.6, 3 out of 5. There's a 3 out of 5 chance, or a 0.6, which is equal 60%. All right, so there's the other options that mean the same thing as this. So that's the probability. That's the probability of not choosing a green. All right, and I know this isn't in your book, but I'm going to go ahead and add this. Let's say, what's the probability of getting a green? I want you to see this. The probability of getting a green is 4 out of 10 because there's 4 green, which is equal to 40% or 0.4. All right, and notice that when I add 60% plus 40%, the 2 equals 100%. So I've just proved again the probability of green plus the probability of not green is equal to 1. All right, so we have, well, I can also call this 2/5. I have 3 not green. Green is 2 over 5 plus 3 over 5, which is going to equal to 5 over 5, which is 1 whole. Or 60% plus 40% equals 100. I just wanted you to see that. I don't think we're getting as much of this as I'd like. So I'd like for you to see that and understand that's what it means to be complementary. That's that defined in an example for you. Okay? All right, let's move on. And let's go on to calculating chance. All right, example number 3. Let's go to example number 3. It says, in a bucket there are 10 balls. Okay, so there's my total. And the balls are marked 1, 1, 2, 3, 4, 4, 4, 5, 6, 6. Okay, so here's the first question. Let me put a 1 here because I got 2 questions here. What is the probability of drawing a ball with a number greater than 4? So number 1 part here, I want the probability of a number greater than 4. All right. So this, by the way, this here is called the sample space. These are all my options, every one of them. There's nothing out of this. So if I asked, and I'll do this in just a minute, but so the probability of greater than 4, okay, does it say greater than or equal to? Let me make sure I'm not messing that up. I think it says greater than 4, all right, it is greater than 4. So none of these count, but 5, 6, and 6. And there's 1, 2, 3 options out of 10. So there's a 0.3. So you can, all of these answers are correct. All of them are correct. And I don't know which one specifically they want, but they want you to be able to see all of those. So there's a 30% chance that if I stuck my hand in there in the bucket and couldn't see, and it's totally random, I put my hand in, I dig around, there's a 30% chance that I'm going to choose a 5, 6, or a 6, or a number greater than 4. All right. Now, here's the second part. Part 2 says, is there a greater chance of drawing a number greater than 4 or a 1? All right, so we already know how much it is to get a greater than 4, but what's the probability of getting a 1? So I come up here to my list, my sample space, all right, and I have 2. There's 2 out of 10, which is 1/5. All right, so I would say, and I'm going to use this, right here. I can compare, right? And so the comparison says that 3/10 probability of greater than 4, which is equal to 3/10, is greater than the probability of grabbing a 1, which is equal to 2/10 or 1/5. So that's the answering that question, all right? And I'm going to throw in one more thing because I think it's worth knowing. And if I asked you, what's the probability, and I have this situation here, what's the probability of drawing a 7, right? There's total of 10, but how many of these are 7? None of them. So we would have a 0% chance of grabbing a 7, all right? And now to go ahead and add this, what's the probability of grabbing a number less than 7, right? How many choices are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 choices that are less than 7 out of 10. So there's a 100% chance, or 100% chance that if I go into that bucket, I draw one, that number is going to be less than 7. So I wanted you to be aware of these two situations. Okay. Well, there's one more example, and I'll be honest with you, I have looked at that example several times. Example number 4, the one about state fair, the state fair application right here. I have seen this example several times and I keep looking at it and it makes no sense to me. So you can try to look at it and make some sense out of it, but I'll be honest with you, I think I just don't get it. So I'm just not going to require you to go through that. If it makes sense to you, please let me know, because I have tried this a couple times and it just doesn't make sense to me. This, I just feel like, is not a really good example. All right. Now your assignment here is to do the lesson practice on page 76, A through G. I'll expect those done. I will do another video with the answers, but I want you to give every one of these a chance, all right, before you watch the lesson practice video. All right, guys, I hope you're doing well. All right, God bless you all. Bye now.